Hello everyone, my name is M. Ganesh Mani, USN 1BE 22EC 056, pursuing my engineering at Sri Venkateswara College of Engineering in the Department of EC. And the course name for today's video is Electronic Principles and Circuit, and the course code for today's video is BEC 303. The topic for today's video is push-pull amplifier. By the name itself, we can understand that this is related to amplification of signal. But there is a factor called as distortion which delays the signal. To avoid that factor, we come across this amplifier known as push-pull amplifier. We'll be learning it in a more deeper and effective way ahead of the video. So the contents that we'll be coming across this video is definition and types, circuit diagram, working, advantages and application of push-pull amplifier. Definition and types of push-pull amplifier. Push-pull amplifier is a type of power amplifier. It contains a pair of active devices such as a complementary pair of transistors. Here, one transistor supplies the power to the load from the positive power supply, and the other sinks the current from the load to the ground. The types or the classes of push-pull amplifier are Class A, Class B, Class AB. This circuit diagram is an example of Class B push-pull amplifier. So these are the two diagrams of Class B push-pull amplifier. The first diagram shows us the circuit diagram where the involvement of two transistors, four resistors and coupling capacitors, where one of the end is connected to plus VCC and the second end is grounded. And there is a load resistance connected across one of the transistor with coupling capacitor, and there is an input voltage attached. As you can see, the second diagram is the involvement of transformer, where there is an input transformer and the output transformer, and the center role plays the same as you can see in the first diagram, as we can observe that there is V1 where there is a resistor and V2 that is the voltage across the second resistor, and they have been connected to ground, and there is involvement of two transistors such as Q1 and Q2. Whenever there is an involvement of cycle of input such as positive cycle and negative cycle, the transformer receives the output also. So we'll be looking it in further in the working of Class B push-pull amplifier. The circuit of Class B push-pull amplifier shows in the above figure clears that both the transformer are center tapped. When no signal is applied at the input, the transistor T1 and T2 are in cutoff condition and hence no collector current flows. As no current is drawn from VCC, no power is wasted. When input signal is given, it is applied to the input transformer T1, which splits the signal into two signals that are 180 degrees out of phase with each other. These two signals are given to the two identical transformers T1 and T2. For the positive half cycle, the base of the transistor T1 becomes positive and the collector current flows. At the same time, the transistor T2 has negative half cycle, which throws the transistor T2 into cutoff condition, and hence no collector current flows. The waveform is produced as shown in the following figure. Output characteristics. The Class B amplifier has a big advantage over their Class A amplifier, that no current flows through the transistor when they are in their quiescent state, that is, with no input signal. Therefore, no power is dissipated in the output transistor or transformer when there is no signal present, unlike Class A amplifier stages that require significant base bias, thereby dissipating lot of heat even with no input signal present. So the overall conversion efficiency of the amplifier is greater than that of the equivalent Class A with efficiency reaching as high as 70% possible, resulting in nearly all modern types of push-pull amplifier operated in this Class B mode. Now let us look into the advantages and application of push-pull amplifier. The output of the push-pull amplifier is the difference between the collector current of the two transistors. This eliminates the harmonic in the output. This method also reduces distortion. Class B amplifier has high efficiency and can work in limited power supply condition. The Class B amplifier has simple circuitry and the output does not contain even harmonics. Crossover distortion is reduced in the Class AB amplifier. As we can see that push-pull amplifier helps us having a high efficiency. It also works in low power supply condition and this eliminates distortion. Now let us look into the application of push-pull amplifier. These amplifiers are used in RF systems. In digital systems, these amplifiers are used due to their low cost and smaller design. These are used for audio amplification in TV, mobile phones, and computer. In long distance communication system where low distortion or disturbance is required, these amplifiers are used. These are also used in loudspeaker system. For amplification of radio frequency signals, this is one of the best example of amplifiers. So these are the advantages and application of push-pull amplifier. Thanks for watching this video. Please do like, share and subscribe to my channel. Hit the bell icon for all the notifications. Share all your comments and views in the comment section below. Stay tuned for more upcoming videos. Goodbye.